Login accepted.
All right, hello everybody, and welcome to this talk. So today we are going to be talking about Spring Cloud Stream. We're going to cover some of the history, some of the past. We're going to talk a lot about what's currently going on, and we're going to quickly discuss about what's in the future plans. About me, my name is Oleg Zhurakousky. I'm the project lead for Spring Cloud Stream and Spring Cloud Function. And the other person you see on the screen is my buddy and colleague, Glenn. You're going to hear his name a lot today because he sort of created this slide deck, and we did this demo and everything else about 2 months ago in Atlanta at the DevNexus. Of course, I'm not going to be as charismatic as Glenn is, but I hope you will enjoy the presentation. He's a guy from Atlanta with a deep southern accent, so it's very fun to listen to him. Anyway, here's a quick agenda. So what is streaming? We're going to talk about functions. We're going to talk about composition. We're going to talk about a lot of interesting things. So the way I structured the demo for today is I'm going to show you some of the quickies, and then we're going to get into sort of a more realistic type applications so you can envision how the problem that I'm going to be describing, how it could be resolved using something like Spring Cloud Stream. So again, yesterday, for those who attended my Spring Cloud Function talk, we talked about the problem in terms of events. Where events come in, we need to be able to process them. There's different types of patterns, the way the events come in. So there's a simple event processing, and there's a streaming event processing, and that kind of implies that these event stream processing is the practice of taking action. I cannot phrase it myself better than what this says from Hazelcast. So event stream processing is the practice of taking action on a series of data points that originate from the system that continuously creates the data. So in other words, it's not one-off, two-off. It's something that constantly gets piped into your processing. So a typical streaming pattern is source processor sync. So what does that mean? It simply means that there's going to be a source of data from which the stream originates, and somewhere towards the end, there's going to be some kind of the end of the world, right? So this is where the whole processing ends. And then there could be as many as you need or want, well, preferably need, processors in between. And those processors, again, I'm kind of skipping ahead a little bit, using, for example, Spring Cloud Function, they could be either composed together into a single process. In other words, composed in a single process, or they can be spread apart by introducing some kind of a connectivity mechanism, which we're going to discuss in a second. So, for example, if you map this source processor sync concepts in Java functions, you will end up with, again, kind of what the message that I projected yesterday, where what kind of requirement can you envision that cannot be mapped to either supplier, function, and consumer. And sort of, in this case, source processor and sync essentially becomes supplier, function, or consumer. So the tools that we're going to be using today is, Spring Boot, Spring Cloud Function, Spring Cloud Stream. So it's almost like you can see it in terms of layers. It probably has to be sort of reversed, because Spring Boot is at the core. I mean, Spring is even below that. And then we have Spring Cloud Function as the programming model. And a Spring Cloud Stream is the enabling model, so to speak. So like yesterday during my Spring Cloud Function talk, I spent a little more time, I think. I got a comment from my colleagues that I spent a little too much time describing Spring Cloud Function from the integrator standpoint. So today, we're actually going to be looking at Spring Cloud Functions effectively from the user standpoint, which basically means you can forget about function catalog, function registry, and all the details of Spring Cloud Function. In fact, you can forget about Spring Cloud function altogether, because you're going to be writing just functions, and Spring Cloud function in that sense is also an enabling type of framework. So let's do a quick demo. And I want to begin by actually a quick show of hands. How many of you are using Spring Cloud Stream or use Spring Cloud Stream? So then I guess you're familiar with this pattern, right? That's how the Spring Cloud Stream originated. So basically, you create a message handler in terms basically you define a method, and using these annotations, you like stream listener and send to, so on and so forth, you identify it as sort of a message handler. Spring Cloud Stream processes those annotations and eventually wraps it, binds the input and output to particular destinations, right? So the problem with this model was because your application clearly is a Spring Cloud Stream application, because you're using Spring Cloud Stream-based annotations. So in other words, the kind of, remember yesterday, and I'll show it in a second, how I was able to just plug in, add the dependency of Spring Cloud function web, and the same function became REST endpoint. I was able to add streaming dependency, the function became streaming handler, and I could continue and add more dependencies that will wrap this function in specific handlers. Well, this would not allow you to do that, because in the end of the day, it basically becomes you're coupled to this application to be a Spring Cloud Stream application. So, and again, there's a lot of knowledge that you would have to have that we analyzed and realized, you know what, if we follow a certain convention, you don't need to identify that the source for this function is going to be called input, or you don't need to identify that the output for this function is going to be called something else, right? Because this could be inferred, for example, from the name of the function, which you'll see in a second, right? But what it also means that if we move, at least in some cases, you do want to map things, you do want to use your own naming, your own mapping, then you can use it into configuration, which allows you to simply change at the startup the naming, the configuration, as opposed to have it inside the code, which now you have to rebuild, recompile, and redeploy. So we basically walked away from this model, and now we're using Spring Cloud function. So what does this mean? So we're going to basically write a and again, I showed it yesterday, but it's a rudimentary kind of quintessential demo to showcase the function-based processing. So we're just going to write a simple function and return v to uppercase, right? And we're going to basically make it a bean. And if you look at the difference between what's the commented code and the code that is not commented, you can quickly see that in this particular case, where is the input coming from, or where is the output going to come from, or to go to? And this is what I was saying earlier, that this is where we can start inferring names, right? So if I know that the name of the function is uppercase, and I know that because I'm going to process this function rapid, so I know that for a fact, then all I get, the convention right now is going to be uppercase in 0, uppercase out 0. That's the name of the output. And Spring Cloud Stream provides a way to map it to a more convenient name for you if you wish to do so. But remember, in Spring Boot, we try to, as we say, it's an opinionated framework, so we try to come up with initial configuration, the default configuration, something that allows you to, can you guys hear me? Yeah, something that allows you to run something without a single piece of configuration. And in this particular case, that's exactly what I'm doing. So I have absolutely, just verifying, I have absolutely empty configuration file. I'm not providing any properties from the command line. And the only thing I have is I have this pump file, which basically says that I have Rabbit binder. And what that's going to do is going to introduce Spring Cloud Stream, and it's going to sort of instrument this function by simply binding its inputs and outputs to a particular destination. So now, all of a sudden, it's still a function for you. You still look at it as a pure function, but inside of the context of Spring Cloud Stream, it became a message handler. So I'm going to use RabbitMQ. So again, I cleaned everything up. So we can see there's no exchanges, no queues, everything is good. So now I'm going to start this application. And all of a sudden, you see that there is a destination that was created. So another benefit of Spring Cloud Stream is that, again, for development purposes, you don't need to even create a destination. We'll auto-provision it for you. So the mechanism is, if you have it, use it. If you don't, we'll create one for you. And that works the same way for Kafka, for Rabbit, for every binder that exists for Spring Cloud Stream. So now I can simply send a message. Well, I use exchange. So you can see uppercase in, uppercase out. 0 stands for the index because we support, we're not going to cover it today, but we support multiple inputs, multiple outputs for reactive cases. So the 0 identifies the index of the input, but in the case of imperative functions, it's always 0. Okay? So I'm just going to send hello Krakow. And we can see, well, I should probably add a system.out print line, but we can see that a connection was made, the message was sent, and we can see, at least from the console, that the messages came through. Okay, the problem why I can see it in the queue, because for those of you familiar with Rabbit, Rabbit introduces the, actually let me just do it instead of trying to, so let me just create out. And I'm gonna from Exchange show to queue. I'll explain in a second what I'm doing. Okay, so let me just send another message. And now we can see that there is a single message in the out, and I can go there and get the message, and we can see hello Krakow in uppercase. What I just did, basically RabbitMQ is the not like a direct destination, so you send to Exchange, you retrieve from the queue. Okay, so Exchange gets bound to the queue, but we don't bind by default anything to the output, because when you'll see it in the future, in the next few minutes, because when we start building pipelines, you create from right to left, you create from a final consumer and all the way to the left. So in other words, the output will already exist by that time. So what I did just for the demo is I simply created the output and bind it manually to the Exchange. So I send it to the input, and I bound output to the output queue so we can see the message that arrived to a final destination. So that's basically the basic Spring Cloud Stream. Okay, so how am I doing in time? So far, so good. Any questions so far? By the way, I would suggest you to ask questions in context if you have it. It's much easier for me to answer it that way than wait till the end. But of course, you can also wait till the end. So let's go back to the slides. So now, kind of to summarize, that Spring Cloud Stream is the framework that binds your code to the sources and to the targets for processing, right? So in other words, once the messenger, and those sources could be messaging system, could be pretty much anything, right? So once the message arrives to a particular destination, the Spring Cloud Stream has this concept of a binder. It hears effectively that, like message listener, that the message arrived. It retrieves the message and invokes your code on your behalf. And the code is represented as functions. Okay? And once the function returns, the output is created, it basically sends it back to the destination that is configured or that is inferred by default. And in our case, it was basically inferred, right? So because we did not pre-create destination, it was there. There was nothing there, so Spring Cloud Stream auto-provisioned those destinations for you. So again, very good for development, very good for demos. Obviously, not very good for production because you don't own the messaging system. So, and we'll see in the next demo where we have certain configurations where certain things are expected to be there, certain things could be reconfigured for conveniences, and so on and so forth, right? So, just like in any Spring Boot-based application, most of them, you just need to add the dependency and things will work. But as you grow your application, as you enhance it, you will probably need to start adding extra configurations to fit your purpose. All right, so let's go about the next demo. So Glenn has a hobby. He's an avid fisherman and a kayaker, right? So he's, unless he's coding, he's somewhere in the water. And thankfully, Atlanta area has tons of different lakes, creeks, and they're all infested with crocodiles and snakes and things like this. So plus, rains and various different weather anomalies that we have in the south of the United States that you obviously heard of, makes you want to be a little cautious when you go out because things could change. Huh? Alligators. Crocodiles, alligators. Potato. Kartoffel. All right, so he loves to kayak, he likes to do. So what Glenn does is he goes into various different US government websites and checks for conditions. So what we're going to do is, and I'm skipping because Glenn has this passionate way of describing where he goes and how he, why it helps him. In fact, if you look at the video we did in Atlanta, he puts on a life jacket, gets the fishing rod and everything else. So that's kind of how he is. But I'm not, like I said, as charismatic as he is. So let's go back to technical stuff then. So, so what we're going to do is we're going to say, listen, okay, well, this is something obviously we can do from just go on the website and kind of click through and sort of figure out what's going on. But let's say we want to be able to automate this process and to sort of, let's say, for example, I want to receive notification on my phone or an email or something along those lines that about these various different types of creek, and I want to build a process that automatically monitors it, and so on and so forth, right? So going back straight to the demo, actually. So I'm going to close this for a minute. We may come back to this particular one. And so Glenn, again, wrote an application. I'm not going to run it to you, but I'm going to show it to you. So it's a, can you guys see the code? Oh, I think you do. So basically, this is a single application, and this specifically was designed or made to project the monolith, basically what not to do, right? So in this particular application, it's still a Spring Boot application. It does everything. It goes to the US Geological Survey website, I believe that's what it is. It pulls the data from it. Then it does some transformation, some polishing, blah, 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 and then it produces the report, right? So again, it's done all in a single application, which means you get all or nothing, right? But let's start thinking about this in different terms, right? So what if you, it works for some cases, but what if you want to expand this application? There's immediately a problem for introducing any kind of change, because since it's a monolith, basically all your retrieve functionality, all your store functionality, everything stops while you're updating the code. So in other words, you can't just look at it sort of in the compartments. You look at it as the whole thing or nothing at all, right? So any change would have to be rebuild, recompile, redeploy. Rebuild, recompile, that's like redundant. Sorry. Because you always want to say in 3, right? But rebuild and redeploy. So what we're going to do is we're going to basically partition this application or compartmentalize it in, again, to fit this pattern of source process to sync, right? And we're going to do a little more, but we're going to discuss it in a few minutes. So first of all, let's start from the beginning, okay? We want to be able to source the data, right, from the website. So we're probably going to write some kind of a source, right? How are we going to do it? We're going to do it using Java supplier, right? So why do we think we want to look at the source in a separate way? Well, think about it this way. You want to periodically collect data. Obviously, for the purposes of some notification or whatever, maybe you want the latest one, only the latest report or latest data, right? But maybe in the future, for the historical purposes, you want to be able to store this data in intervals of 1 hour or whatever to maybe start checking for some patterns or just for whatever other reason there may be, that you need, right? Then you also think about, okay, well, further on I need to process this data. So now I want to be able to introduce some kind of a processing, and that could actually expand in itself, right? But now, as soon as you introduce something else, you're thinking, okay, well, if I need to maintain the processing data application, and I need to, for example, perform some maintenance and stop it or something like this, should I also lose the data that I'm collecting in certain intervals? Probably not. Right? And if we move even further to consumption of the data, does this mean that you should stop consuming the data if all of a sudden the source stops producing the data? So in other words, you start looking at these things as like, okay, well, I maybe, or for example, what if my source producing the data much faster than I can process? What I can do? Can I do something dynamically to enhance, to speed up the processing of the data? So all of a sudden you start asking these questions and you say, okay, well, if I partition it in such a way and introduce some kind of a persistent store in between in the form of, let's say, Rabbit destination or Kafka destination or any kind of messaging system, for example, or even a database if you want to, right? We just don't have a binder for that, but you can easily write one. Okay, then all of a sudden you can start collecting the data and pull the data. So in other words, your source, your processor, your sink becomes completely independent, isolated applications, yet working in unison to give you exactly what you're looking for. So the other thing we're going to do, we're going to also, instead of writing everything as a monolith or sort of jamming all the code into a single class, what we did is we extracted every piece of functionality that we could sort of map to a function supplier consumer into a separate library, which basically contains the classes, which we're going to use as a dependency. So now, for example, when I look at my consumer, let's go start with the producer. When I look at my producer, I only have a single class, because which is actually very simple. Because all I'm doing here is I introduce a single bean code. Let me just remove this. It's almost sensitive, but it's not. It's just the API key for something I'm going to do later on as part of the demo. I had to buy it. So basically what we do for the source, we introduce a supplier, right? So again, the question here, okay, well, supplier is a very different type of function, because if you look at the consumer and function, they're being invoked based on something that happened somewhere else. But what about supplier? That's the source of the data, right? So this is where, for example, that whole demo thing that I showed you before, I wouldn't say the word, you wouldn't use the word breaks. This is where you need to do something extra. So let's look at the configuration. And in configuration, we have a few things in the producer. And one of those things is we configure a poller for a fixed delay. In fact, you didn't have to configure the poller. We also have a default configuration for the poller, but it's going to be 1 second. But obviously, for the demo, it would defeat the purpose, because you don't need 1 second intervals for something like geological data. And you also can be rate limited during your demo, live demo, which wouldn't be good at all. So we introduce basically a delay of 15 seconds. So every 15 seconds, the system will, the polling consumer that's provided by Spring Cloud Stream, which you don't see, it's internal, that's the benefit of the framework, is going to poll this supplier. And what does this supplier do? The supplier basically makes a call back to this get creek data and pulls it from the geological, from the USGS website. Right? And that's pretty much it. And what does it do? Nothing else. It basically returns it. And something else will send it to somewhere. So again, let's look at the configuration, what will happen. So first of all, by default, if we didn't provide any configuration, who can tell me what would be the name of the output? Out 0, right. So when we go here in the configuration, we say, okay, well, first of all, the fact that we introduced sprinkle function definition here, again, we didn't have to do it because we only have one function, but I always say, listen, just because we try to do as much as we can to avoid any kind of unnecessary configuration, it's always recommended to explicitly identify it, because if you don't and you introduce something else, as long as there is more than one function, the system will not be able to figure out which one do you want to bind. So, and you start like thinking like why it works before, but now it doesn't work, and I only introduced this dependency. So that could be the reason why. And there's a statement in the log telling you that, but it's not always easy to find because we don't always read the logs. Right, Marcin? So, so now what we're also doing here is, remember how I said you can do something for convenience, because, for example, Creek Data Supplier, that's the name of the function. Now, the destination that your administrators of the messaging system created called output. So actually called something different, right? But even, sorry, disregard what I just said. So the name of the function is Creek Data Supplier, but maybe that's not the name that you want to use for the output for reasons, whatever. It may be too long for you, maybe inconvenient, maybe that's just the name of the function, but you want to change it to something more architecturally sound for that particular use case. So what we're doing here is we're mapping this name to the name output. So now every binding configuration that we are going to use after that, we can use the word output instead of Creek Data Supplier out 0. Okay? So that's, again, very convenient, because if, let's say, you change the name of the function, this is the only place where you would need to introduce the change, because everything else is mapped to the word output. Okay? So kind of a little sleight of hands, a little misdirection, right? So, and what we're also doing here is what I was trying to say is that our administrators, let's say, may have created, or if they didn't, we will create, but it's going to create a destination with the output destination called USGS data with a group name foo. So now, again, going back to the Rabbit console, we have nothing except for uppercases, right? So I'm going to start, well, I'm not going to start. Well, I'm going to start. The thing is that, again, with Rabbit, remember that since there's not going to be, just like in the previous case, since there's not going to be anything bound to the exchange output, right, to the USGA data, then the messages are going to be dropped, right? So we're not going to see any kind of, we're going to see data coming in, but we're not going to see the data itself, because it's going to be dropped, because basically nothing is listening, okay? But we want to be able to see that it's working. So effectively, when you're building a pipelines, you want to start from consumer and move left as opposed to from producer right. You can do the other way around. It's just that producer might be producing the data that you're not consuming yet and maybe losing. Okay? So application started, we go to Rabbit console, and we can see that our USGA data exchange was created. So everything's fine. The messages are flowing there, and we can see it from the numbers popping up right here. Okay? So I'm going to stop it for a second. And so, okay, so we are convinced we have a source, it produces the data, everything is good. So now we want to be able, but it produces it in some format that we're not really like. So we want to be able to introduce some kind of a transformation to that data. And again, it doesn't really matter what we transform it to, even though I'm going to show it to you. But we're basically receiving the data, and we are transforming it to a list, and simply return a list. Now, this transformer is actually, so we had a supplier, but this transformer is the pure function, right? So it receives function of message string, but it outputs list of Creek measurements. So again, you see what you see here is quite a few interesting things. So first of all, like I said, now we have a function. Second of all, we are outputting not some string, some basic output. We're actually outputting a list of some POJO types, right? Some custom types that we created. And how does, but now I have to send it to some destination. So again, this is the benefit of both Spring Cloud Stream and the framework. So any kind of type conversion that has to happen will happen, so the message will successfully get to a destination. So again, can we start this? Can we start this transformer? We start it. Again, we go to Rabbit console. We can see Creek data, right? So we already have something. So now what we're going to do is we can start a producer again. And all of a sudden, we have a queue. And you just see the numbers starting popping up on the queue. So right now, the messages are starting to get piped into the transformer. But we're not there yet. Okay? So transformer, basically, we receive the data in one format. We use the transformer. We send it to a destination. The transformer received it from that destination, did some type of processing, send it to another destination, and right now we need to finally consume this data, right? So one thing that is important to understand here is, like yesterday I was talking about function composition, right? And I also mentioned that a lot of people misconstrue. Actually, the reason why I'm monitoring my phone is because later on I'm going to be at least attempting to send SMS through this application, so I needed to hear the bing, and Martin is spamming me, so thank you. Where was I? I was talking about function composition, right? And a lot of people misconstrue. So we use the pipe symbol to compose multiple functions into a single function, which is, again, a Java functionality. But because of the pipe, people misconstrue that and think that we're building some kind of internal pipeline and asking me questions about how can I handle error at individual components within this pipeline. And I have to always explain, it is not a pipeline. The result of the composition is a single function, okay? But when we do source processes sync in terms of like introducing some type of persistent destination in between, yes, we are building a pipeline because they're independent components, right? So just to actually, since I'm on the subject, might as well show it to you, right? So I can start transformer, I can start a producer, so I can stop them individually, but here, if I stop right now, the transformer is listening to what's being sent by a producer. If I, for example, kill the producer, transformer doesn't really care because it listens not directly to the producer, it listens to the destination to which producer deposits messages. So producer doesn't deposit anything, there's nothing to do, right? What's other interesting thing here is that, here's what I'm going to do. To show you that, again, one of the value of Spring Cloud Stream is like how do you deal with some type of like connection or misconnection or something like that. So I'm going to do the clean on the Rabbit, which means shut down the server, clean all the exchanges and queue and everything else, and you can kind of follow the logs. You can see that all of a sudden the system recognizes, the Spring Cloud Stream recognizes that all of a sudden you have lost the connection, and it attempts to reconnect. And in this case, not only to reconnect, it attempts to reprovision the destinations that you may have missed because you cleaned your process, right? So in other words, that's another benefit. You almost have to not worry about this because it's going to be sort of taken care of for you by the framework. All right. So, and that's sort of the value of building something as a pipeline. However, when we go to a consumer, so consumer is something that finally will consume the application. It is implemented as a consumer, and we have consumer string, consumer SMS, consumer log. Well, you'll see it in a second, right? And we also have another function called report creek measurements. And if we look at the configuration, this is you can see something here. You can see the Spring Cloud function definition. I'm actually using the pipe. I'm actually composing two functions into one. If you think about it, so I have two consumers, one for logging, one for sending SMS. And if you think about the function that sends SMS or the function that provides the logging, or let's say you have a function that writes something to a database, that's a completely separate functionality. But I want to massage the data a little bit, and I don't see the value of this data existing outside of the context of me consuming it, right? So again, I'm just doing it for the sake of argument, saying that it is architectural decision. You may want to separate it into two different components within the pipeline, or you may want to use function composition and say, even though I address my complexity by breaking it apart into simple problems, I can reassemble the complexity by simple function composition. And in this case, what I'm doing is I have a function that generates report from the data that arrived from the transformer, and then it pipes it into, well, I just used the word pipes it into. It is because, well, it pipes it into the next function, but it is the same function. Okay? Because what?
You have to close the reminder.
Yeah. I used to be good at that. Closing everything. So anyway, so let's now have some fun with the demo. Okay, so now a few other properties here is that, so we're mapping, so I'm going to actually start with the log. And what I'm doing here, actually I'm going to show you a little bit. Okay, so now I told you we have two consumers, right? So if I look at the code, you can see a little extra boot configuration here is I'm saying, like, just because I have two consumers, it doesn't, like, which one is going to be bootstrapped, right? And we basically have say, listen, you bootstrap this consumer if the sprinkler function definition is generate report log, and you bootstrap this consumer if function definition is generate report SMS. Okay? So now, even though I configured one, only one consumer will, actually only one bean is going to be created for that purpose, right? So I'm going to start it, and we're going to hopefully see the creating logger, and we did, in the console, right? So we created logger, and now I can start the transformer. And I'm going to start the producer. And this is where things should start moving. And they did. So all of a sudden, we have this live data coming from the US Geological Survey website being analyzed, being processed, and Glenn can happily go to Big Creek, Roswell, and Peachtree Creek, Atlanta. Okay? He cannot go to Outlet River because something is wrong there. Okay? So I'm going to keep it running. But what I'm going to do is I'm going to pretend I have another consumer. Okay? So remember, so we basically have the same consumer. We can use the same application, but we're going to start a different instance, and we're just simply going to change configuration. And right? But I'm going to like this, keep an eye on this group name. So I'm going to keep the group name the same, unchanged, right? And now, after changing it, I can simply start another consumer. So there's a 15-second delay. Okay, so we got logging, but from SMS consumer, we got nothing. Okay? Let's wait another 15 seconds. And now we got SMS, and did you hear it? And there it is, right? So, but the important part is, look at the consumer. We still have two logging messages. So what happens is that we're load balancing. So think about what I said earlier today, that I didn't even stop my application, my pipeline at all. I just added another consumer, and all of a sudden they start load balancing. Obviously, with the 15-second delay, it's pointless, but you can imagine how it would be if you have some processor intensive or a super fast stream, and you cannot consume as much as you produce, right? So again, it keeps sending SMS. I only have few SMSs left, so I'm going to stop it right now. And again, look, I'm only stopping the consumers. Actually, I only stopped the SMS consumer, right? So what I'm going to do right now is I'm going to stop both consumers because, so remember how I told you keep an eye on the group name, right? So we used different destinations, different functions, but we kept the same group name, which allows us to say that these two consumers belong to the same group. So, which means that the Spring Cloud stream, as a framework, recognizes that you just added several consumers to the same group. We're going to load balance them, right? But if I'm going to change this to SMS and start consumer application, and then I'm going to change it to lug, and start the consumer application. All of a sudden, everything will work the same way, with the exception that now we switch to the true pop-sub model, because you're going to say send one SMS, one log statement, one SMS, one log statement. So imagine, again, a different type of use case where you're not trying to load balance. You're actually trying to say, I'm going to keep logging or maybe sending some SMSs or whatever, but I also want to store this data somewhere for historical purpose. All right, demagogues aren't smiling. So what happened? Sorry, let me just. It's maybe the whole auto creation got in the way because we pre-created the load balancing queue before. Now it's sending it there. Most likely. So I can do this clean, but again, I'm going to clean the rabbit destinations, right? But oh, actually, I have. You can see I had one consumer running. I had the other consumer stopped, but it's not the point here is that it automatically recognized and recreated the destination, so you can see Greek data log. So I'm going to actually do SMS, SMS. So I'm going to start another instance of the consumer, and then I'm going to start so we can see another consumer destination. So I'm going to start a transformer, and I'm going to start the producer, and now we'll be able to see everything working as sort of expected. So logging. You can see logging, and you can see the SMS. So all of a sudden, the single message goes to both destination, and my phone is pinging again. Okay? So how much time I have? About 8 minutes. So any questions so far? All right. Sorry? All right, I barely heard you ask, but I'm going to try. So if I have multiple so yes, remember how I said that the zero index indicates the index of the output? We do support functions with multiple inputs and multiple outputs for the reactive use cases. So when functionality basically, so we have you can define your function as flux, and then within it you can use the tuple library from Project Reactor, and basically you can go up to 8 inputs or up to 8 outputs. And like I said yesterday, the reason why we limit at 8 because that's how far the Project Reactor tuple goes, right? So, and I always joke that if you have more than 8 outputs, then you probably have different problems. But yeah, so we support this. Unfortunately, it's out of context of this presentation. This requires a bit more elaborate setup, but there are test cases that you can look at, and yeah, we support that. So hopefully that answers the question. All right, last but not least, since Marcin was kind enough to sit through my presentation, I want to credit him for creating something, like he requested it for Spring Cloud Contract, if I remember correctly, because you wanted to do something, and I begged you not to use channels because that's an internal detail. So you said, give me some abstraction and so on and so forth. Well, long story short, this abstraction became one of the most popular components of Spring Cloud Stream, which I enjoy the fact that it is. I don't enjoy the fact that sometimes people overuse it for the purpose of where things would be even simpler if they use a framework properly, but because this one is also too simple to use, people just use it everywhere. And that is a stream bridge. What is a stream bridge and why would you be able to use it? So, like I said, we have binders for primarily messaging systems like Rabbit, Kafka, Solus, and so on and so forth, right? But what if you have a REST request that you want to send and send it out to Rabbit, for example? So you would need, so basically you need to somehow create like a REST controller of some type, and then somehow bridge it to a stream, and that's why it's called stream bridge. So I have it stored right here, piece of code, so we can basically use it. Oh, and I need to and again, so this is interesting. I'm sending it to blah. What is blah? Just something, like you name the string, I'll send it there. Okay? So again, I'm going to clean the Rabbit console just to make sure that there's nothing there, right? So I'm going to send an HTTP post request, and somehow it should go to Rabbit. And that's exactly what's going to happen. And Olga, I will use curl today, so. Done embarrassing myself. Thank you, Victor, for yesterday. I'm going to send message just to localhost there and just hello. And you can see sending hello because this is the log statement. And if I go to the console, we have exchange called blah. So again, one of the benefits of, or one of the beauties of Stream Bridge is the fact that, yes, you can send to anything. The whole mechanism of Spring Cloud Stream with auto-provisioning and everything else will still work. So it's not just something that provides you a little utility class. It is a full-fledged component of Spring Cloud Stream that allows you to basically send messages to destinations, which also allows you to say, listen, like, for example, elaborate on your a little more on the question that I was asked earlier. Let's say it's not a multiple destinations, but let's say it's the different destinations, some kind of a routing type of thing, right? So you want to be able to maybe have a consumer receive messages and then say, I want to be able to, based on this condition, send it to foo, and based on that condition, send it to bar. Again, there are different ways of handling that situation, but in case if you don't want to use those ways or for whatever other reason, you can be lazy and use Stream Bridge as well for that. There's nothing wrong with that. It is still Spring Cloud Stream, but like I said, that's where the abuse sort of comes. Anyway, we are pretty much at the end. I'm actually 2 minutes early. That's surprising. Any more questions? All right. Go ahead. Yeah, so every function is, in this particular case, in this case, we actually have two cases. We have a single function which represents a single service, and we have in the consumer, we have actually a composition where two functions represents because they're composed into a single function. So yeah, it is still single function that is a service, right? So they run by themselves, they run independently. Through additional configuration, they're bound to a destination. So the way they're orchestrated is that The left side sends messages. So in other words, they are not aware of one another, but they share a common destination. And that's the orchestration piece.
My question is more from Devoxx perspective. How to deploy it more.
Oh, so actually, I had a little bullet point, but I was not planning to talk about this. So you can do it manually, like I did, or because if you want to, complicate your life, or there's a product within Spring portfolio called Spring Cloud Data Flow, which effectively automates this whole thing for you. So it automates this, so you just deploy apps. You actually has a graph we can drag and drop. You literally can do the same. You can write the same applications. Okay, don't even provide any configuration, just empty configuration. And then say I'm going to deploy this as a source, this as a processor, this as a sink. It will automatically generate all the necessary configuration. So within Rabbit or within Kafka or within the type of binder that you're using, and it will. So you don't have to do anything. You just simply like a CF push kind of thing. Like you just push this application, and it will orchestrate them for you, and it will start. It will instrument them for you, and it will start them for you. And because it's not, Spring Cloud Data Flow is not like an ESB, it's not a server, it's just a mechanism to address exactly what you're asking, because once the pipeline is running, you can shut down the data flow completely because it has no effect on the runtime of the application. Other than, from what I already seen, they have some interesting way of monitoring, and again, so that's for that purpose, you can see some data about the application. But other than that, the applications still run themselves independently, and so on. So again, actually a good question, because what I want to show you that it's not that difficult to create pipeline manually, but obviously in a production environment where you're dealing with people who may not be familiar with code, like the ops people, then you can simply say you point to this jar file, point to this jar file, this is your source, this is processor, this is sink, and again, using GUI, and it will do the rest for you. Yes?
Spring Cloud Steam support steps as well, or we cannot say the steps?
Supports?
Steps.
States? Spring Cloud Stream doesn't really deal with states, because we use the states in the Spring Cloud Stream context is the persistent stores like Rabbit Exchange and queues or Kafka topics or whatever. So destinations in between, right? So, however, in case streaming, so again, we have Kafka binder, we have Kafka streams binder. So obviously, in the reactive sense, there is but that's not Spring Cloud Stream. That's basically our integration with case streaming that provides support for the state. Yeah. Again, also Spring Cloud Stream is built on top of another framework that I used to be part of, Spring Integration, which does have a component called aggregator, which does, again, it's not Spring Cloud Stream, it's the component. Effectively, it is your code that maintains the state, not the framework. But in this case, the aggregator is a component of another framework, and that framework actually is responsibility to have a component that maintains the state. Okay? So if you choose to use that, you can use the aggregator provided from Spring Integration. It's configurable. You can implement it as a function, but then in this case, it's going to be that component that's going to maintain the state. All right, guys, I'll hang around, but thank you so much for coming, and enjoy the rest of the conference.